So, Higher Maths Unit 2, Practice Assessment, NAB 2, Outcome 4 on the circle. Now there are 12 marks available here. In order to pass the outcome, you need to get 8 of those. And this all starts off with the equation of a circle. Now, all circles have got the same shape, they're all similar to each other, and the simplest one you can draw is one that is centred on the origin. Centred on the origin with any given radius. To get the equation of any curve, you will need to find a connection between the coordinates. For any point that lies on this circle, what's the connection between y and x? Well, there it is there. The x coordinate and the y coordinate form a right angle triangle with the radius no matter where you place that. So you've got a simple connection with Pythagoras. The two shorter sides squared and added must give the longer side squared, which means that x squared plus y squared equals r squared is the equation of a circle centred on the origin with radius r. Now, if a circle isn't centred at the origin, and that's the only other variation you could have with a circle, if it isn't centred at the origin, but instead is centred at some point AB, then you can adapt this equation to cover that situation, which covers all circles. If the circle isn't centred at the origin, you can recreate this equation by changing these variables. If you took A, because it's A along for the x coordinate and B up for the y coordinate, if you took A off of the x coordinates of all the points, that's the same as this axis shifting along by A. All the x coordinates have been reduced by A. And similarly, if I move the axis up by the amount B, so all the y coordinates have been reduced by B, I've got an equation centred at the origin again. So this same equation would apply to that situation. The only difference is I shortened my coordinates. The x coordinates, instead of being whatever the original values were 8 less. They all moved back. So that means I've got x minus a squared. Similarly with the y coordinates, I shortened them all by b. So y minus b squared equals r squared would be the equation for any circle at all. Centred at AB and with radius r. Notice that's the square root of whatever the number is at the end. So the first question in the NAB, that's question 9 part A, is just to show that you understand this equation. You'll be given the centre of a circle and its radius and asked to write down its equation. So that, for instance, it might say a circle is centred at 7, negative 2 and it's got a radius of 6. What's the equation of the circle? A circle centred at 7, negative 2 and it's got a radius of 6. What's its equation? Well, this is its equation. Notice the similarity with y minus b equals mx minus a, because it involves the same principle. If you have a line with gradient m that passes through the point AB, then the equation is y minus b equals mx minus a for the same reason. That line passes through the point AB. If that point was the origin, then the equation would simply be y equals mx. That's the equation of a line passing through the origin with gradient m. So if I shorten the x coordinate by a and shorten the y coordinate by b, arrive at with that equation. Y minus b, mx minus a. It's the same here. So I've got x minus the x coordinate squared, y minus the y coordinate, taking away a negative, so that'll be plus 2 squared, equals, and that's the first mark for putting those two parts in, equals 6 squared, but since I've already got that in a suitable form, I don't want to write 6 squared to have to write it all again as 36. So I'll put 36 in straight away, and you have to have 36 to get this mark. 6 squared won't do. There's 2 of the marks. Now, this form of the equation is the easily understood geometrical one. That's the way that it was derived geometrically. You could, however, expand that algebraically. That means squaring these brackets to arrive at this other equation, the expanded equation, which would be squaring the brackets, square the first, square the last, in the middle twice the product, so it's minus 2ax. Same with this. Square the first, square the last, in the middle twice the product, minus 2by equals r squared. And then just gather the terms in order. X squared plus y squared. Then the single terms, minus 2ax minus 2by, except you've now got three parts here that all just form the constant at the end. You've got a squared and b squared. If I bring the r squared over, minus r squared equals 0, which would be the expanded form. X squared plus y squared minus 2ax minus 2by plus, just call that c, equals 0. Only that's not the way you'll probably see it written down. It'll be x squared plus y squared and then plus 2 and then perversely gx plus 2fy plus c equals 0, even though x, y are in alphabetical order, and of course g and f are reversed there. And the only reason for this form, being the form that it's given, is for the cosmetic convenience of having a positive there, which admittedly is what you tend to do with general forms of equations. However, I would suggest just ignoring this cosmetic convenience and concentrating on that which bears a greater resemblance to the original geometrical significance of it, because all that's happened is twice the product. Where's the centre gone? It was glaringly obvious here. It's not too disguised here because they've just been doubled. Just as you accepted here, it's whatever's been subtracted, same here. So it'll just be half these numbers and change the sign. And the last part would be, how does that relate to the radius? We had this a squared and b squared, just sticking with the geometrical one rather than the f's and the g's. But you get the same result both ways. Minus r squared was replaced by c. So taking the r squared over, I've got a squared plus b squared, which just means square the centres, minus the c. So I can get the radius just by doing square the centres and take away the number at the end. So if I had, and this is what you'll get in part B for 2 marks, the equation of a circle in that form, the expanded form, x squared plus y squared, let's say plus 4x minus 6y plus 4 equals 0. Now it's only again 2 marks, one for getting the centre, one for getting the radius. Whether you think in terms of f's and g's or the original a's and b's doesn't matter, it's the statement of the final answer that counts. And it's simply by this, well, the centre. Well, the centre comes from these 2 parts, which were originally twice the product. So that means the numbers have been doubled. So that would have been a plus 2 and that would have been a minus 3. So that means that's going to be the opposites, what's been subtracted. Opposite sign, half it. Opposite sign, half it. Easy. No a's or b's or g's or f's. Opposite sign, half it. Opposite sign, half it, because it came from twice the product. The radius, well, if I take that square over as the square root, it's simply going to be, well, what was it again? I had appearing in this, when I multiplied it out, the square of the x coordinate, the square of the y coordinate, and then the radius, joined that together to make it. So it's just going to be the square of that, negative 2 squared, the square of b, so that's 3 squared, subtract the number at the end. Subtract, in this case it's minus a 4. Just have to move that out of the way. There you go. Minus a 4. Watch if that's a minus 4 at the end, because then subtract that would become a plus 4. So in this case it would be equals 4 plus 9, which you're free just to jump in with. Just start and say, well, square the radius, square the centre, 4 plus 9, take away the number at the end, square root of 9, but don't leave it like that, you have to finish it off, equals 3. And those are the 2 marks. Notice these 4 marks, question 9 is worth 4 marks, are simply for stating the results. Stating that part of the equation and stating the radius squared. And this part, extracting the centre and calculating the radius. It's only 1 mark. You don't need to mention anything about A's and B's or these F's and G's. Now, the next question is to prove that a given line is a tangent to a given circle, which doesn't apply specifically to circles, would apply to any curve. If you've got some curve and a line is supposed to be a tangent to it, then it means it intersects at one point. It's an intersection, so you would carry out simultaneous equations with these 2 equations, substituting one into the other. At that point of intersection, the coordinates have to be the same. In particular, the y coordinate of this would equal the y coordinate of that. The only difference with circles is the equation of the circle is written in the form of x squared plus y squared. They're all jumbled up. It doesn't just say y equals. So you can't just say that equation equals that equation. You'll have to carry out the formal substitution. Well, as an example, if you had the line y equals 2x plus 11, and the circle x squared plus y squared plus 6x plus 4 equals 0. I've deliberately missed out the y term because in all the variations of the NAB there isn't a y term. Perhaps just to simplify the algebra slightly for you. Anyway, it says, is this line a tangent to that circle? Substitute one into the other. Wherever you see y, write this y instead. So x squared plus, now that y is equal to 2x plus 11 squared plus 6x. And if there had been a term here that said so many y, it had been so many of the same 2x plus 11. Plus 4 equals 0. That's a critical stage. You've got these two equations. Where do they cross? You'll find that out by substituting one into the other. Or you can think of it just as equating the y's if you like. Now obviously the worst you're going to get here is x squared, so this should all tidy up to a nice little quadratic equation, and that's the next step. But as far as the marks are concerned, the first mark is for carrying out the substitution. The next mark will be for expanding it out. So it's the standard square of a bracket. So it'll be square the first, 4x squared, square the last, 121, twice the product, 22x doubled is 44x, plus 6x plus 4 equals 0. That's the second mark. The marks are just dropping on the page. The final bit is just gather that up into a nice little quadratic. 5x squared plus 50, it's looking good because it's always looking good when you've got a common factor that will simplify the factorisation, plus 125, there you are, full of fives, perfect, and that's your third mark. There are 5 marks for question 10, there's 3 of them already. Now you've just to show that the line is a tangent to the circle because it hits it only once. That means this equation should only have one solution, but of course it's a quadratic, so it should have 2. So what you have to show, it's got 2 equal solutions. It's got equal roots. Or instead of that, you could just work out the discriminant and show the discriminant is 0, because that also means it's got equal roots, which means it's a tangent. I'll do the factorisation first. Take out the 5, I've got x squared plus 10x plus 25. And if it works, that should be a perfect square. So it must be x plus 5, 5 5s are 25, squared, just double check it all works, 5, x squared, 25, and then 2 5s are 10, equals 0. And then from that you can say it's got equal roots. Equal roots which means line 1 is a tangent, that's why it's always handy to put these numbers in, is a tangent to circle 2. And there's the remaining marks. 1 mark for ending up with this expression, which shows you've got equal roots. You don't need to go as far as to say x equals -5, because that alone means you've got equal roots. And then 1 for the statement. Equal roots means the line is a tangent. 5 marks. Or you might decide just to use the discriminant. Now you can use the discriminant with those 3 coefficients, but 5 is going to be a common factor throughout it all. Or you can use the discriminant just in this part. You're probably better off taking out the common factor, so you just use these numbers. Which means I've got, if I work out b squared minus 4ac, I'll have b as the coefficient of x, and that'll be 10 squared, minus 4 times a is just a 1, and c is a 25. So that's 100 minus 100, which equals 0. I've got b squared minus 4ac equals 0, which means, as before, the line is a tangent, or line 1 is a tangent to circle 2, or just line is a tangent. The 2 marks being getting 0 for the discriminant, and then saying that that means it's a tangent. Probably safer to say the same thing though, b squared equals 0, and then that implies equal roots. So line is a tangent. Maybe I should have put that in. Now for question 11, and that means there's 3 marks left. Question 11 is just worth 3 marks. You have to find the equation of a tangent to a circle. Now, you'll not be given the equation of the circle, you'll be given the centre of the circle. So let's just say this is at the centre 3, -4. And the point where it's going to be a tangent. This isn't going to be a case of to find the equation of a tangent to a curve. I'm going to differentiate it and then substitute in the x value to get the gradient, because as far as the higher course is concerned, you don't know how to differentiate the equation of a circle. So it's just going to be done geometrically. You'll be given the centre of the circle, not the radius. Radius is irrelevant in this case, and the point of tangency. So say that's the point 7, 8. And the question would be, given that configuration, what's the equation of that tangent? Call that t. Now, this is just done geometrically. It's not going to be done by differentiation algebraically. Geometrically, this would be the case. The tangent to a circle is at right angles to the radius at the point of contact, at the point of tangency. So if that's a right angle, and it says what's the equation of the tangent, well, that's just how do you find the equation of a line? You need its gradient, you need a point on it. There's a point on it. How can I get its gradient? By reference to the perpendicular line. In other words, get the gradient of the radius, and that'll give you the gradient of the tangent, and there you are. And that's why there's only 3 marks. First part would be, what's the gradient of the radius? Well, I know the 2 endpoints of that line segment, so it's just a case of the difference in the y coordinates over the difference in the x coordinates. 8 take away -4 for the difference in the y coordinates. 7 take away 3 for the difference in the x coordinates. That's 12 upon 4, which is 3. So this radius has got a gradient of 3. Well, immediately that means that the gradient, and that's the first mark, I should have said, immediately that means this tangent must have a gradient of the negative of the reciprocal, -1 upon 3. That's your second mark. And then finally, for the equation of the tangent, y minus b equals mx minus a. I've got my gradient, I've got my point on it, so it's just y minus the y coordinate, which was 8, is the gradient, -1/3, x minus the x coordinate, which is 7. And as far as the NAB's concerned, substituting those values in gets the 3rd mark, and there it is, 3 out of 3. Simple geometrical fact. The tangent to a circle is at right angles, is perpendicular to the radius. So get the gradient of the radius, get the gradient of the tangent, and that's all you need for a line. What's a point on it, and what's its gradient? Finish that off if you like. You won't lose or gain any extra marks by tidying that up. So I just will, because I can't resist that. So I'll multiply this side by 3. 3y minus 24, and that leaves -1 times this, if negative x plus 7. So I'll just write that as x plus 3y, might as well take it all to one side, minus 31 equals 0 for the equation of the tangent. No marks for that, but also no marks off if you make a mess of this bit. 3rd mark stops there. Now, try the questions. So for number 9 then, the first part. What's the equation of this circle? Centre 4, -3, radius 5, put it into the basic geometric form. X minus the x coordinate, squared. Y minus the y coordinate, squared, is equal to the radius, squared, because it came from Pythagoras. Square everything. But don't leave it like that. Change that to a single number, 25. So I'll just rewrite this. X minus 4 squared, y, but that'll be plus 3 squared equals 25. There's the 2 marks. 1 mark for the 25, and the other mark for subtracting these centres from the x's and y's. What's the centre, and what's the radius of this circle in the expanded form? Well, it's not been disguised that much. It's always handy to write the centre just under these 2 numbers, because all that happened, they were doubled. So change the signs, and then half these numbers. It must have been +4, but -5. Half the number, but the opposite sign, because originally it was x minus the centre. Radius, that just comes from the centre squared, take away the number at the end. 4 squared negative 5 squared. Or if you're feeling brave, just jump straight in with 16 and 25 because there's only 1 mark. There was 1 mark for this and there's 1 mark for this. Minus the number at the end, but be careful if it's a negative. Because if it's a negative, it'll be subtract that negative. So that'll be 16 and 25, but plus 8. And that'll come to 49. Don't leave it as the square root of 49. Finish it off. The radius is 9, and there's your second mark of part B. 4 marks altogether. Number 10 then, show that this line is a tangent to this circle. Doesn't matter about a diagram because you're doing it purely algebraically. So in that sense, it doesn't matter that this is a line and that is a circle. You just want to show that the solution to that pair of equations involves just 1 point. Well, substitute that into that. So that's x squared plus, so wherever you see y, carry out the substitution. Take out the y, it's no use to you, and put in the 4x, because you just want one variable in the equation to solve it. So 4x plus 9 squared. Whoops, minus a 4x. No mention of y, no, it doesn't matter. Just makes it a little bit easier. Equals 0. There's your first mark for substituting that equation into that equation. You don't need to write this bit down, but I just prefer to do that. Just state what I've done. Substitute 1 in 2. Next mark will be for expand that out in readiness to tidy it up. X squared plus, square the first, 16x squared, square the last, 81, twice the product being 36, doubled, 72. Minus a 4x, minus a 13 equals 0. Mark number 2. Tidy that up. 17, a bit nasty. Not so nasty if the rest involves 17s somehow or other. 72 take away 4 is plus 68. Well, that's fine because that's 4 17s. 81 take away 13, that's also 68. That's your third mark. Now there's only 2 marks left now, depending which way you want to proceed. Either factorise that and show that you've only got one solution, but remember that's really a pair of equal solutions, so you'd say you've got equal roots, so it's a tangent, or get the discriminant. So the discriminant is 0, which of course means you've got equal roots, so the line's a tangent. Well, the first thing I'm going to do is take out this 17. Even if you're going down the discriminant route, there's no point leaving a big common factor like 17 in. Take it out. 17 times 1, obviously, and that's 4 17s, 28, and then the 6, and that's 4 equals 0. That's a perfect square. That's exactly x plus 2. X times x and 2 times 2. That's exactly x plus 2 squared. You might have done it as this first of all. X plus 2 times x plus 2 equals 0. You don't need to write the square then and then just make the next statement. Equal roots then. Equal roots, because both brackets give the same answer. Equal roots, which means 1 is a tangent to 2. Line is a tangent, however you want to write it. That on its own would do. Or line 1 is a tangent to circle 2. But the marks would be 1 part here for arriving at the factorisation that involves a perfect square. But better to write that though as x plus 2 squared. But you don't need to. And the next mark is for saying, well, I've got equal roots, so it's a tangent. Or you could go down the discriminant route, which would be, what's the discriminant? What's b squared minus 4ac from this equation? Now, it doesn't matter whether you use this equation or the form with a common factor taken out, you'll still get exactly the same result. If the discriminant is 0 for that, the discriminant will be 0 for that. If it's greater than 0 for that, it'll be greater than 0 for that, and so on. So using that form of it, I would have b squared is 4 squared minus 4 times the a times the c. And of course that's 16 minus 16, which is 0. That's the fourth mark if you want to take that route. And then the final mark is for saying, well, that means it's tangent. Probably better to write, if the discriminant is 0, that means you've got equal roots. And if you've got equal roots, that means the line is a tangent. And there's your 5 marks, depending on which of these 2 forms you want. Now, if you mess it up, so that you've done a mistake somewhere and ended up with a quadratic, that factorises to 2 brackets which are different Well, first of all, you know you must have made a mistake because the question says show it's a tangent, so the brackets must be the same. But if you can't find where that is, don't try and fuddle it up at the end and say, oh, they should have been equal. And if they were equal, it's a tangent. You have to work with what you've got. If you do make some mistake and end up with two brackets, say it's an x plus 2 and an x plus 3, for instance, the only conclusion, don't forget it's always equal to 0 because these are equations. If you don't have these zeros in, you lose a mark. If you end up with this and you can't figure out where the mistake was, then your conclusion for the final mark must be consistent with this. You've already lost the mark there somewhere, wherever you made your mess. You'd have to say, oh, two separate routes, which means the line is not a tangent because it intersects twice. Or instead of doing that and saying, oh, two distinct routes, so it's not a tangent to get that mark, you might have done it this way and ended up with a discriminant which was greater than 0. You might have worked out b squared minus 4ac and it turned out to be something like 17. You'd have to make a consistent statement. That means you've got two distinct routes, which means the line is not a tangent, even though the question said so it is a tangent. Best at that stage just to go back and figure out where your mistake was though. And finally, number 11 then. Find the equation of the tangent to the circle. Nothing to do with the equation of the circle, a simple little bit of geometry. To find the equation of this tangent, the equation of a line, I need a point on it, got it, and its gradient. I'll get that from the radius, because the tangent to a circle must be perpendicular to the radius at the point of contact. So first, the gradient of the radius, I'll just call that CP. So I'll get the difference in the y coordinates divided by the difference in the x coordinates. So that will be c to p. Negative 6, take away negative 1. Negative 6, maybe just jump straight in with plus 1 for take away a negative. Difference in the x's, 2, take away 1. So it's negative 5 over 1, so that's just negative 5. Which means that the gradient of the tangent itself will be the negative of the reciprocal, so that will be 1/5. And there's the first 2 marks out of the 3. 1 mark, just for the final answer though, 1 mark for the gradient of the radius, 1 mark for the tangent, and then finally, what's the equation of that tangent? Y minus b equals mx minus a. And the mark comes from simply substituting in the correct numbers in the correct place. Y minus the y coordinate, y minus the negative 6. Gradient of the tangent is 1/5. X minus the x coordinate, which is a 2, and strictly speaking, that's the third mark for 3 out of 3. Not even having to tidy up this y plus 6. So there's your third mark, but you'd probably go on and say, well, that's y plus 6 and finish off what we've got. 5 times this side then. 5y plus, because they take away negative, 30 equals x minus 2, because it's just 1 times that side. Then I'll just think I'll put it in this form. 5y equals x minus 32. Of course, there's no marks for doing this, nor are there any marks off for that. There are your 3 marks for the 3 out of 3 to make the 12 out of 12. Easy.